Good afternoon, and thank you for joining today's webinar from Spec Innovations, Practical DoDAF using Innoslate. My name is Elizabeth Steiner, and I will be the moderator for today's webinar. First, let's go over some quick housekeeping before we get started. During the presentation, feel free to send us questions, and we will get them answered in the question and answer part of the webinar. You can also interact with us on LinkedIn through the Innoslate user group or through Twitter using the handle @Innoslate. The webinar is being recorded and we will make it available to you after the live presentation, so be sure to keep an eye out for it in your inbox. Now I would like to introduce you to our presenter, Dr. Steve Dam. He'll be sharing with you how to leverage the power of Practical DoDAF through Innoslate. Dr. Dam is the president and founder of Spec Innovations, as well as one of our DoDAF training instructors. He has been involved with research, experiments, operations analysis, software development, systems engineering, and training for more than 40 years. Dr. Dam participated in the development of C4ISR Architecture Framework and DoD Architecture Framework. He has also received an Expert Systems Engineering Professional Certification from INCOSE. He currently is applying systems engineering techniques to various DoD, DOE, and commercial projects. Feel free to send Dr. Dam any questions through the LinkedIn user group or send him an email. And now I will hand over the controls to Dr. Dam and we will get started.
Thanks, Elizabeth. Let me bring up the agenda for today. We're going to talk a little bit, very briefly, about what an architecture is, just in case there's some folks out there who don't know what we're talking about. Also about the DoDAF itself, just a little overview of that. And then talk a little about what we mean by model-based systems engineering. We have a little different definition perhaps than INCOSE has, so I think that might be helpful. And then talk a little bit about how model-based systems engineering can produce the DoDAF models and viewpoints. We'll also talk a little bit about the ways to develop more cost-effective architectures. And then we'll go into a live demonstration using the Innoslate tool, and we should have plenty of time for questions. So first of all, what's an architecture? Well, first of all, you got to remember that everybody is going to think that you're talking about a house or a building when you start bringing up the word architecture. But we really mean it as a more abstract way. We're thinking about information architectures, enterprise architectures, technical architectures, as we used to call logical and physical architectures. Architecture may be one of the most abused words in the English language today, and we're going to continue to abuse it all through this presentation. So some definitions. This is helpful to look at what the DoDAF definition is of an architecture. And it says a structure of components, their relationships and principles and guidelines governing their design evolution over time. So you can see it's a lot more than just a physical architecture or a building kind of architecture that you're used to maybe thinking about. I found that definition to be a little amorphous. I can't quite get my hands wrapped around it. So I prefer the one on the right. We put it together as a unifying structure defined in terms of elements, information, interfaces, processes, constraints, and behaviors. And particularly behaviors is an important factor to us because the reality of the world is it's dynamic. Things are changing, and things change in different kind of behaviors, and we want to understand those, and we want to control those behaviors so we understand what it is we're getting when we actually create a system or build an architecture. So what that definition implies is that you have a number of bins of information. Sometimes we call them dimensions or schema if it's a database, that you want to capture the information and they're related to each other. That has a fancy word called ontology, and that's what we're actually trying to do, is make sure we can capture that information and express it in a way that people can understand it and see how things are dependent upon one another. So one of the things about elements of an architecture is that it requires an operational context. Context is really important to understand what you're talking about. What are you abstracting out of the problem? What are you dealing with inside the problem? Mission to me is also a very important factor. Maybe your mission is to be the best business in your domain, or maybe it's an operational mission in terms of Department of Defense. Requirements, another thing to look at, and of course those are the requirements to accomplish the mission. So that's what you're really looking to do, and you want to be able to decompose those, maintain them, evolve them over time, because things aren't fixed. It's a very dynamic environment we're working in. Again, relationships among requirements, how they related to each other. We have conflicting requirements very often, constraints that come in that cause problems, laws, policies, regulations that you have to deal with. Organizations and roles, that's another key part of this, and understanding who's doing what their roles and responsibilities are, and of course the relationships among the organizations, because particularly in the Department of Defense, there are many different organizations that have oversight into different parts of a problem. Behavior and functions, again, the behavior part I talked a little bit about a minute ago, and the relationship among those functions. And of course the data and information from analyses, you want to capture that and bring that into the architecture and make sure you understand the why. This is the why did I do things a certain way? Why did we head down a certain design path? And of course those constraints, as I mentioned a little bit earlier, they might trace from originating requirements, or they may evolve as just from the technologies and things as you're trying to apply them to the situation, or from the operational constraints that might be occurring. Of course, architecture is seen as the highest level of design. It's really sort of the top. It's the umbrella. It provides that overall context for the deeper architecture. And decisions. Decisions are very important to capture along the way. Again, particularly the kind of programs the Department of Defense is involved in, they happen over many years, lots of different people cycle through. You want to capture the decisions, why they were made, and the context of the decisions, so that people can understand and make better decisions maybe in the future, or at least different ones. Okay, so that's kind of a very thumbnail about an architecture. I got a 2-day class on this, so you can imagine that I'm giving you a very quick overview at this point. So what's the architecture framework, though? What does that do for us? Well, that was set up by the Department of Defense. It started out with the C4 ISR architecture framework back in the 90s, and it's evolved into the DoD architecture framework. And this is the latest picture of DoDAF 2.0, and they have different viewpoints. What they want to do is capture the information in different viewpoints so that different constituencies can understand it and look at the information and work with it. And so that's kind of that top-down capability to operational to services to systems. There are different people who do these things. The capabilities, operational views are often done by the operators, and that's your combatant commands and people like that in DoD. Your services and systems are often done by the uniformed services, the Army, Navy, Air Force, Marines. They're the ones who provide the systems, the train and equip part of their mission. And then standards, if you look at the standards viewpoint, that's the agencies that are in the Department of Defense. They have a lot of standards. They also play in the services and systems area, so you can see how those different viewpoints might fit. The project viewpoint, of course, is cross-cutting now, and so is the data and information viewpoint. And, of course, the one that's always been there is the all-view set of views. So this has been an evolution over time from the different DoDAFs, and they keep adding views. There's been discussion of adding security viewpoints and all kinds of things, so from other frameworks that are out there. But really, if you think about it, this is just a series of templates or ideas of how to capture information and relate them to each other. So that's why it's a framework. A good way to deal with this is understand the terminology. And they use the term model. So the models are what are described in these different viewpoints. And if you add data to those, then that gives you a view. Okay, so that's a view of the architecture itself. So in other words, the model is the template, the data is the information about the specific architecture you're working with, and then that creates a view. Now, if you take a set of these views together, and by the way, those views used to be called products, so you might hear that term used from now and then. I still use it a lot myself. From that, then, you create a viewpoint. And so that set of views gives me that viewpoint I'm working with. And, of course, those set of viewpoints we just saw in the previous slide. Now, if I want to build an architecture, I have to take those various viewpoints, bring them together, and that becomes my architectural description. Again, this is as it is according to DoDAF. That's all interesting and that's useful, but again, there may be more information you want to capture than just what the DoDAF has, and we're going to talk about that as we go along as well. So here are those models that I just mentioned a minute ago, and I won't go through them all. They're very involved, each one of them, but it turns out there's a lot of overlap between the type of information you're capturing. For example, a lot of these are mappings. You see the mappings? These are just matrices mapping things together, capabilities to operational activities, things like that as you go through this. Some of the other things that are there that are common, if you look at your OV5s, you're going to see some similar things when you get to the Services View 4 and your Systems View 4. Those are similar kinds of things, and you're looking at same thing with the OV6s, ABC. These are different ways to try to capture some of the dynamic information about the architecture. They've added the portfolio project views, which is good. Portfolios, a lot of timelines in this as well. So there's a lot of ways to visualize this information as you capture it so you can understand it better. Again, here's your services and your systems views. Along the last one is the standards views. And again, take a look at that overlap very carefully. The services view 9, systems view 9, services technology forecast, systems technology forecast. Again, you can see this kind of parallel pattern between these things. What this is meant to be is the services are a higher level abstraction of the problem, and then the systems are implementing the services. So that's, again, you get that feeling of a decomposition, and that is what that was trying to do with it. We could look at it then as separate views, or we can look at this together in a way that makes it more coherent and easier to work with and easier to develop. And that's the approach we've taken applying systems engineering to this framework. One of the things that has always been there and it is confusing to people, and one of the reasons why they kept moving, they had templates in earlier versions. In the last version of 2.0, they got rid of all the templates and just said, well, there's certain information you're supposed to be providing in each of these views. And that information can come in many different forms, and it's just really the form that you want to communicate it in was the idea. Well, that's all well and good, but that caused a lot of confusion to people too. And so they had some suggestions of the types of things you could do. And of course, if you look back in the previous versions of the DoDAF, you will find examples of how you could communicate. But that has always been there. They didn't say how you're supposed to do this. There's no specific methodology like structured analysis or object-oriented approach were dictated. This was to give you ways to capture information and relate the information together. Some people call this the data-centric approach or a data-centric viewpoint, and that's kind of what they're trying to do with this. So one of the things, though, is a lot of people look at these architectures as just a collection of a bunch of diagrams and documents and things that communicate the information, capture the information, relate the information to each other. But I like to look at it a little differently. I want to work from a repository, a place where all this comes together. I can work with the information, and then it's visualized for me directly from the tool, from that repository. And this is where the Innoslate tool comes into play. Tools like Innoslate have this ability to visualize the information that's captured in a database. I think we do it in a way that you'll find, I think, is more transparent and easier to use than anybody else, but that's the basic idea. Plus, we actually draw all our diagrams from the repository. So what do we mean by model-based system engineering? Well, MBSE, by the INCOSE definition, is here on the left. It says model-based systems engineering is the formalized application of modeling to support system requirements, design, analysis, verification, and validation, beginning with conceptual design phase and continuing throughout the development of later life cycles. All that's saying is I'm applying some kind of systems engineering to the entire life cycle. Great. In fact, I think we've been doing that for years. Probably the first time you drew a flow chart could fit that definition. Some people have equated model-based systems engineering to a specific technique, and that specific technique they've been pushing is SysML. But like I say, model-based systems engineering in this definition has been around for a long, long time. Probably back, certainly I ran into it back in the 70s, and it predated that time period. One of the things I saw fairly recently, about a year ago, was a workshop slide that said model-based systems engineering is systems engineering. And that's a good way to think about it, that this is just a technique or a way to capture the information, relate it, and express it quickly and easily. So if anything, what model-based systems engineering is really thinking about is how to provide some automation to improve your systems engineering practices and reduce costs. So what are some of those techniques that are being used? In view graph engineering is still the #1 technique I see. Let's face it, PowerPoint, Visio, those kind of pure drawing tools are very common and applied all through the architecture community. Those are okay, except for the fact that for next time you have to change them or reuse them or try to understand the information that's in them, I have to redraw them, I have to adjust them. It's not any really different than just creating a paper document and it sits on a shelf. With the model-based approach, you can apply these other techniques, structured analysis, IDEF, UML, SysML, I've seen that used many times. BPMN even has been used on a number of different architectures I've worked on over the past. And a fairly new comer to this area is the lifecycle modeling language. It's the one we're using now because it really encompasses these other techniques and lets us really create something that meets almost everybody's needs throughout the life cycle. So characteristics of a good model-based systems engineering, again, interactive models, not just drawings with a database. Simulation, discrete event, and Monte Carlo to verify the models. You need ontology and visualization. Again, some of those techniques have a visualization component to them only. The ontology is kind of buried, or they have an ontology only kind of approach to it, and that's not the right answer either. We need both because we're human beings. We need to understand what the data is and be able to see it to understand it better. So various visualizations from the database are required, and then of course report creation. Part of the model-based thing is that you're supposed to be producing out of your technique, out of your tool, the reports you need, because you still have to produce paper. We still have to be able to do that because those become legal documents at some point in the process, and so it's actually still critical to do that. So how does MBSE produce DoDAF models and viewpoints? Well, one of the things is a lot of the tools, particularly Innoslate, uses a dashboard where we can work from the information of the different types of products, and in the process, in the background, you're capturing all the information into a database that then can be used to link them together in other ways, tie it together with other parts that you want to do in terms of system engineering, and of course capture statistics and export PES. It turns out that the DM2, which is the DoDAF Meta Model 2.0, PES, physical exchange specification, is a requirement for a conforming tool to meet DoDAF requirements. Another thing you want to be able to do is be able to build one diagram and get many of the products. Again, an action diagram in our parlance in LML is what we call a combined OV5B, OV6C. Now what that does is that means I'm using one diagram to get two diagrams within DoDAF. Now, oh, by the way, there's services view equivalents and systems view equivalents as well. So that's 6. So for one diagram type I can work with, understand, and learn how to use, I'm actually getting 6 different DoDAF products eventually. Well, that's a savings right there. And of course, in Innoslate, we have ways to visualize them separately. So if you want to see just an OV5B or just an OV6C, that's also part of it, and it's free. You don't have to redraw it. You don't have to do anything different. Again, drag and droppable is something you're looking for. Again, all modern tools have that. Very useful and easy to, makes it much easier to use. Another thing, though, that I found extremely useful, particularly for this kind of functional modeling, is discrete event and Monte Carlo simulation. Discrete event, because you want to be able to see a timeline, one pass through the process. But with what happens is there's usually a lot of variation that goes on. So the Monte Carlo runs it many times and deals with the variations that you might be able to put into each of the actions. So again, I'll try to highlight that when we get into the tool a little more. Again, if you're not comfortable you starting from an action diagram, it's where I like to be, but a lot of people say, hey, I want to work with that sequence diagram or some other diagram, maybe an activity model or some other diagram, IDEF0. Those are all available within the tool. They all tie together. They generate one from the other, so you can work with them easily and do what you want to do and work in the view you want to work in and feel most comfortable. Again, the classic IDEF0, I think you'll find that's a very powerful diagram for us. We've had a lot of help from the academic community to get that right, and so we believe that's probably the best IDEF0 tool out there today. Simulations, I mentioned both discrete event and Monte Carlo. The discrete event simulation gives you a Gantt-like output for the timeline, and then if there's a charts tab which lets you go to the charts, and the charts include a cost chart. So you actually can see the cost, and the resources show up above the Gantt chart, so you can see resource usage. So again, all those things you want to look at that are affecting your simulation, that are affecting the actual design, are right there in your discrete event simulation. So that's your one pass through it. But as I said, you can put variability into in terms of time, in terms of resources, in terms of almost any numerical value in the tool, and that can have an effect on the Monte Carlo simulation. There we give you a distribution. In this case, I'm showing you the cost distribution, but there's also resources, there's also the timeline distribution as well. Excuse me, I'm getting over a cold. So another thing that you want to be able to do is then build the physical model. Again, your OV1, your services view 1 and 2, your systems view 1 and 2 are all these kinds of basic models. And a lot of people like to have that classic block diagram, which I'm showing on the left. You can have it that way, or you can add in pretty pictures and lightning bolts and backgrounds and all that kind of stuff to get you a prettier OV1. All that's available within the tool. And so it gives you a very expressive way to start looking at your physical architecture, and particularly the pictures helps a lot. I find that the pictures are something a lot of people can resonate to. If you notice also that these buttons, it says decomposed, you can actually decompose these diagrams, go down levels. And this is another way to get layers into what you're looking at and drive down into more detailed problems. So if you're trying to do a very large problem, usually architectures are starting with the big picture, but you want to drive them down several levels. You can do that easily here as well. In fact, everything in every element type in entity type in Innoslate is decomposable. But another thing that's important is that connection. How are these related to one another? And again, relationships are set up within LML so that that's where the complexity of the language comes in, is in that set of relationships, that almost everything's connected to everything else within the ontology. And what that allows then is then you to be able to trace through and find things throughout. And we also set up what are called bi-directional links. It's automatic that if you make a link in one direction, that the reverse direction link is established for you. That's extremely helpful if you're trying to start from the bottom up. You're trying to work into what's the components and working up to the requirements. Every one of the diagrams, by the way, in the tool have the same diagram framework, and you'll see the sidebar has the information you need to be able to manipulate and work with these objects all the way through the development. Another thing we've done is create a documents view. Too many of these kind of products are external to the tools. You do your AV1 is your classic project plan plus project report, right? Because if you deliver it first to be the project plan, and then when you add the findings section, that actually becomes your project report. And by doing that, that makes for a very simple, coherent product output for an architecture study. Well, that's nice, but if I have to have that external to my database, then I can't link the other things behind it. Like, well, let's say the findings. I want to trace my findings back to the why. What products, what things, what decisions, what other information led to that finding. Were there risks associated with it? Those are all things I want to be able to link together with this and be able to find quickly. By having it in our documents view, you can do that, and documents view has baselining and all the other things you want for configuration management. I think you're going to find that you won't be doing a whole lot in Microsoft Word once you start getting to use this in conjunction with the rest of the database. Interactive matrices, of course, there's lots of matrices, as I mentioned earlier in the DoDAF. We have those. When you use these matrices, they actually are establishing relationships between things. So if I click an X between capabilities and the operational activities, that actually creates a relationship between the two. And so that actually becomes very, very important in looking at how you look at the problem. So how can we develop a cost-effective architecture? Well, a lot of the problems of architectures becoming shelfware is that they have no clear relationship to a mission or design. Often they're also done in the abstract. Users aren't involved. That's often at DoD. That's often because our users are pretty busy right now, and so it's hard to get their attention. But sometimes you can find good user surrogates and people like that to help you through it to make sure it's realistic, and then take the limited time you have of your users and put something in front of them that you can walk them through. Another thing is to focus on the to-be without understanding the as-is. I've seen that happen many times. People try to come up with their vision architectures, or they know what they want to go build, but they haven't spent the time to understand what it is today and where the real problems are. And because of that, then there's no rationale for going from as-is to to-be. There's also no way to develop that transition plan that you might need for it. Another thing we've seen, and this is the problem with any database or any kind of architecture study, is everybody uses a little different language to mean things. And so you need some kind of internal governance processes for, what languages are you going to use? I mean, when you say tank, what kind of tank do you mean? Or be more expressive, use more longer words for it. Make sure you put in descriptions for each entity in the database. Capture pictures wherever you can. These are the governance processes that you need to decide upon, and then how you're going to review it and make sure it's right. So another thing we're working on is something called model-based reviews, and we'll probably have a webinar on that later. So that's the kind of thing that will be helpful to you in those governance processes. Another thing is, of course, it's paper architectures. When I say paper architectures, I mean anything you've just used Word or Visio or PowerPoint or something to create the architecture. That's not a living model. It's not something you can work with, reuse, and update easily and quickly. And of course, the complete lack of traceability. If you haven't really linked everything together in your data structures, then finding things, tracing them back to each other. Let's find that decision. Well, what was that decision made upon? Was it responding to a risk? You know, these are things you need to understand and be able to know in your database or in your architecture. Otherwise, it'll be forgotten, and those things will have to be rediscovered by someone further downstream in the life cycle. So how can we avoid learning those lessons learned? Well, simply have a clear, simple methodology, a simple technique. Again, that's the theory. In our case, we use LML because that's what we think is out there now. Processes, we actually have a number of detailed processes we use. One's called middle out. It's actually a very powerful way to look at the entire systems engineering process. And, of course, the tools. And our tool today is Innoslate. We've replaced 6 other tools using Innoslate, and the cost savings there has been tremendous by itself. Planning and replanning, of course, you have to realize you're going to be replanning, and so you want to have that ability to update the database and use the database for all your planning as well. And we've provided that in the tool, in Innoslate as well. And, of course, training. Everybody needs to understand how to work together as a team, and recognize you're probably going to need refresher training from time to time, particularly as you bring in new people. You need to bring in them and integrate them into the team. That's a good time to bring it and re-guide everybody into what you're doing and how you're doing it. So the techniques, again, is the things, that's the bins of information and how they're related to one another. That's your ontology. That's a key part of it. Also, any visualization standards that you're using to communicate so people can understand it. I think you will find LML gives you that and gives you that full set of things you're looking for. The processes, this is the middle out process I mentioned. We have that initial AV1 draft happening fairly early in the process. AV1 being delivered in the final AV2 at the end. As you go through, the different DIVs come into play, your OVs, SVs, and of course services views are kind of usually precede those SVs a little bit if you're going to include them. And of course the capability views, I notice I'm showing them coming in late. You may start with them very early, ideas you have, but you're probably going to end up with them at the end when you really have it all together and linking it together. So a little bit this is what I mean by bottom, middle out, is when I'm working kind of in the middle, which is the scenario process level going on, business process level if you're doing business systems, and then building up to the capabilities views and down, driving it down to the services and systems views. So I pretty much start at that operational level when I'm working this. And then standards views. And don't forget your project views. And again, these are all happening. If you look at that bar at the bottom, you have to be able to generate any of these products at any point in time, at least the status of where it is. So that's a key part about having this in a database. If I have this in a database, I can deliver that by just running a report, giving the output to my customer or to my boss, and so they can see what's going on quickly and easily and have that information available as they need it. And of course, one of the things we've found that's kind of neat is you can do a ConOps in the middle of all this architecture, and that's a great way to interact with your user community. If you build that ConOps as part of the architecture, then they will see how you're thinking about using it, and then give you some course corrections early enough in the process that you can make the adjustments you need to make prior to it going out there, and you'll gain more user acceptance of the architecture, which is a big step towards actually, getting the concept to the next phase of development. The tools. Again, you need database capabilities, you automatically generate diagrams. Requirements analysis is still an important part of this. A lot of people forget that. Think about architecture as not requirements. No, there's a lot of requirements you have for an architecture. If nothing else, you have laws and policies you have to follow. rules and regulations you may need to follow. So there's standard processes you need to analyze and understand and extract. So requirements becomes important there too. And of course, I've mentioned simulation several times, so that's important. So how do we determine the appropriate mix? I start with the technique because I want to get the theory right first. And again, that's where LML comes into play for me. Identify the tool to support the technique, and right now, unfortunately, Innoslate's the only tool that does that. We're hoping other people will pick it up and use LML as a basis for their tools. And of course, develop or obtain a process, and again, the process I showed you in the middle out is well documented. It's in several books, and it's available at any time if you want to use it. Or use the one your company has. That's certainly fine. And of course, optimize all three. Make sure the technique, the tool, and the process work together, and everybody knows how to use it. And then work with your customer to make sure you're producing what they really want. That's essential. So, I think we've got a little bit of time. Let's go ahead and jump into the actual live demonstration portion. So hopefully everybody can see the dashboard when you sign into Innoslate. And remember that it's free to explore the tool. Just go to the innoslate.com website and sign up for the free version. You can play with the tool to your heart's content. The only constraint on the free version is you're limited to the number of entities. Total number of entities is 200. And the Monte Carlo simulation is not available in that one. If you need a more extended demonstration capability, you can contact us for that. So here's the main dashboard. This is the main one, and there's a getting started, and we'll go back for a second on that and show you what that is. You have actually a list of things you can choose from. So depending on what you're interested in, you can start from there. So let's start with architecture. And I can create a new ConOps document, or I can go in and create new DoDAF products, and that's actually going to take me to the DoDAF dashboard, which I'll take you to in a second. And or you can import the DoDAF sample problem and see how, we've used a tool that gives you a good example, something to work with and look at and see how things were working together. And of course, the basic online documentation. For the project managers in the group, this is really helpful. If you're managing this architecture study, this tells you who's done what when. There are hyperlinks into the products that were changed and adjusted. So that's very powerful. There's also a model maturity checker. This lets you see how good your model is, and you can run it at any time. And if you're not sure about what that means, is then go ahead and click that button, and you see you get this dialog up. It shows where the problems are, and you can then go through and fix the problems if you want, or decide those aren't important. But at least that way you have an understanding of what's going on with it. Those heuristics, by the way, came to us from Stevens Institute of Technology, and we do appreciate that. If I scroll down here, you see the statistics panel, and what that is shows you the different entity classes. And in some cases, like statement has both the statements and requirements, so you see both of those. And then the outer ring is labels that are associated with things, and those are important as well. And we'll get you into that a little bit more as we go through. One last thing that's really important, and this is on all our dashboards, is this feedback form. So if you have ways you'd like to see us make improvements or things you'd like to do, please just add it right here, type in your message, and send it to us. Okay, so let's go over to the DoDAF dashboard. And so when you click the DoDAF dashboard, by the way to get to that is through the menu bar here. You can do the DoDAF dashboard and then pin it, and this little pin symbol, and I've already pinned it to this one so you can see it here. And what this is a set of tabs. You can see the AV products, the CV products, the DIV products. So they're all there as you go through the list. Let me go back to AV for a second. So when you see that, again, up here I can create a new one, a new AV1, or I can edit one I have already working. So this would be the one I would go to, and I will in a second. The other thing you have is the AV2, which is the PES. That is your physical exchange specification export. It's an XML file. Our XSD is available, so that's all open. Another thing that's down here on the left, notice we had that statistics model on the previous dashboard. Well, this is actually tying it to the DM2 nomenclature using that ontology. And you can see the different aspects of how many we have of each one of those. And there's a feedback form again, please. Please use it when you can't need to. So if we want to go to look at the AV1, and clicking on that, we'd get the AV1 here come up in this is called Documents View. You see on the left here is a hierarchical viewpoint of each one, so I can go immediately to the findings section if I want, or come back up to the beginning of it. Each of these areas here are actual text. This italicized text is part of what's there originally. I can italicize, I can unitalicize it, I can make it bold, I can insert pictures, I can insert a table. As you see above here is a table. Hyperlinks, which is very useful, particularly since everything in the Innoslate product has a hyperlink associated with every page. You can then put those in and then tie things together that way within the tool. There's bullets and all kinds of capabilities to look at. Now you can either accept the change or not accept the change. If I accept the change, since I had it baselined, it was the blue bar changed to yellow, and that tells me now that I've made a change, and so I can see that, or I can go look at my previous baseline by coming back up here and selecting that baseline, so I can see my original document unchanged. Let's go back to the main one. So that's a good way to work with. Again, here's your findings down here, so you can work with those as you go through. Any entity here can have a picture associated with it as well by clicking on it. You notice on the left here, the sidebar has the pictures associated with it. You also have a place for comments, and the comments field here is meant for reviewers to use to say what they like or don't like about a particular part of the document. So this is a way you can do some model-based review immediately. And, oh, by the way, this is available in our read-only version. So the free version of the tool allows you to give people access to do reviews to any other database online. Notice over here are the labels. That shows you different labels, and I won't hit that much more detail, but that's available for those used for sorting purposes in the database view particularly. So now once I do that, let me go back to the dashboard for a second. So once I do that, I start walking through the different products. I want to look at some of these other products. So let's take a look at the CV1. I'm sorry, the CV2. And this is the CV2. It's a hierarchy. And if you notice, this hierarchy actually has not just the capabilities, which are up here, and those are capabilities themselves. And again, you can see that. They have a capability label associated with them. But also, there are some activities associated with this underneath. And that's because we connected those through another product, which was the CV6. So the CV6, when I make these connections, actually create a relationship between them of decomposed by. And so that shows up in this hierarchical view, going back to the CV2 that you have here. So that hopefully that shows you a very quick, easy way to work with it. Now, I hope you noticed also that as you're clicking on these, the information about it, the values, are associated here on the left. You can add descriptions. Since capability is a type of action, it has a duration, a start, things like that. So you can start looking at using that information in some different ways as well for what you're working with. So let's go back again to our capability views. That hits most of those. The OV products, lots of OV products. And again, notice I've got the ones I've already worked on as opposed to just having the created ones. So you can keep adding these as you go through. It may get very busy here, but that's okay. That's what you want. You want to be able to see what's available to you. So let's take a look at one of the OV products here. This is the OV1. This gives you an example of using it with the lightning bolts and the ones and zeros and pictures and things like that. Again, some of the stuff we captured information about, descriptions. Excuse me. And those are available as well. Here's an IDEF 0 version of that as well. All that same information is right here and available to you to use. It's all drag and droppable. You can work with it as you need to. If you need to see the whole thing at once, you can just press this little button here on the corner, and it shrinks it all down so you can see what you need. Or you can increase the thing slowly so you can see at different portions of it, of the diagram. This again, all these little features I'm showing you on the sidebar and down here are available on every diagram. And most of these other things are available too in different ways. The reports, different ways to get reports, including SVG output we have now for our drawings. You have the ability to do colors and bolding and all kinds of things with the text. So a lot of capabilities with it, working with it. Another view is the sequence diagram. These are all available, by the way, just from the same menu. I can go back up here and I can pick any of the other diagrams that are appropriate. I can go to an activity diagram instead. It takes a second, but there it is. There's your activity model from the same picture. If I make a change in one place, it shows up everywhere in the database, every other view. By the way, if you do have an open tab with the information, notice I'm using multiple tabs. You have multiple tabs, have multiple windows to work with things. You will have to refresh that window if you've made a change someplace. Here's the action diagram. This is, again, my favorite. Works very well. This brings in our Monte Carlo and discrete event simulator capabilities. We've had webinars about those, and we'll have future ones about it as well. And then another thing I wanted to show you was timelines. That's one of the key things in the project view. For example, this is out of our project view. This is the milestone diagram. These, again, are all live diagrams. They have live values. They have information associated with them. So you can decide what's in each of these and work with them as elements within the database. What I haven't shown you is there's more. You go to the database view, and there's a lot more here that you can work with. Use your database view to filter, find things, maybe risks. I want to see a risk variable here. See my risk diagram matrix. So again, I can work with all these things. It's all visible, all workable within the same framework, that diagram framework. Also, the search capability now is extremely enhanced. If you used an earlier version of the tool, you will find that this is a lot easier to work with and use. Wildcards are available, all kinds of neat ways to use it as well. So that's kind of hitting a lot of the highlights. I want to give some time left for questions in the hour here. So let me go back to our slides and hit you with a quick summary, and then we'll have time for Q&A here. So very quickly, practical DoDAF means using the model-based systems engineering techniques, processes, and tools to develop the DoDAF models. Use the common language. The technique gives you some of the common language. The DoDAF itself gives you a number of terms to use to make your common language. Also, many different places have common system function libraries. Different services have that. They have the same functions, same names, same thing with the operational activities. So these are tools that you can reuse. Also, apply a process that works for your situation. Again, for architecture, I usually do middle out because I usually don't have a lot of requirements. I do have some. I do want to work with them, but that isn't my main driver normally I have to derive things from an operational perspective of today and try to drive out where the gaps are, where the problems are, so I can work with it. And then use comprehensive tools to capture the information and produce the DoDAF products. So now I think we've got about 10 minutes for questions, and please go to the control panel, and I think Elizabeth is going to be asking the questions.
Thanks, Dr. Dam. We've already received several questions. Our first question is, if LML is the answer, why aren't others jumping on board?
Probably because they just don't know about it. It's fairly new. It's only been out for about a year now. The actual language itself is an open standard, and again, they just probably don't know what's available and know the differences. So that's part of what we're out there doing. We're trying to educate people about the differences and why this is a really enhanced approach to doing this work. Go ahead.
Our next question is, are you only available via the cloud, or do you have on-premise offerings?
No, we have on-premise offerings. We actually have always had them. We're actually making a major step improvement in that area in our enterprise version, where we're moving to a SQL database kind of approach back end, and so that's going to make us even more enterprise grade. We've been able to support the user groups we've had in the past, but this will let you scale more to other, and it'll also allow us to go to other clouds. We are looking at the Microsoft cloud, for example, is being looked at by the DoD as maybe their cloud, and so we'll be able to support those kind of things as well.
Our next question is, have you cracked the nut for how to manage architectures where content is in and out of skiffs and other intentional air gaps?
Yeah, in fact, that's always a problem in keeping the data. I tend to like to work system high when I'm doing classified work, and so I try to keep everything at that level. And then what you can do is put labels on classified items. So if you want to extract and put it to a lower classification level, you can. At least will let you go through and look at the document and create a document that is at the lower level classification if you need to export it there. But otherwise, you're keeping copies of things back and forth. It gets very confused and it's very hard. There's no magic around. Certainly, our tool can't solve multi-level security. I've been seeing it for the last 30 plus years trying to deal with it, and there is no magic there. So,
do you have a PES importer?
Not at this time, and of course we're not sure what that looks like exactly, because again, one of the problems we've seen is, like with most quote-unquote standards, it's not very standard, so it's hard to know exactly what we're going to get when we take a PES export from some other tool and try to bring it in. So we are looking into that, but we're not there yet with it. I don't know anybody else is doing that yet either.
Do you make content available as RDF?
As RDF? I don't know what RDF is. So the answer probably is no.
Do you import/export XMI?
No, not yet. Actually, with our new release of the Innoslate 3.2 last week, I believe it was just last week, we have all the SysML output diagrams. So now that actually makes sense. XMI, in case everybody doesn't know, is a specific type of XML used for UML and SysML. And so it didn't make any sense to even try to do that until we had the complete SysML output. So that is something we're going to look at, and we'd certainly be open to what level of interest there is for such a thing. I will point out we have a long list of features we want to continue to add to the tool, but we are very user-driven with that. So if the users in the feedback form say, hey, I really need this and I need it yesterday, tell us and we'll see what we can do, and we can't bring it up in the schedule for development.
You mentioned logical and physical architectures. Will you provide an explanation of how they are used?
Yeah, so our action diagram tends to be more that logical architecture. It's a level of abstraction that's higher, and if you look at your operational views or your capability views, those are higher levels of abstraction. So they're similar to that functional architecture. The physical architecture usually is referring to specific implementations of things, and that's where your services and your systems views come to play within DoDAF. And so that's probably the way I would look at those differences.
Can you interact with tools other than such as Excel that users are more accustomed to using as the user interface?
In fact, we have got a very nice export to CSV and the ability to re-import from CSV. So we can go work with Excel, you can go make changes in Excel, and then we can bring that back into the tool. So that's a new capability with the 3.2 release. We have also built special interfaces using the software development kit to other tools, and if there's a specific one you have to have, and you've got to have it tied to it, and particularly if it's web-based, that's reasonably straightforward for us to do. Again, again, it's one of those priority things as to when to do it, which tools. We are very interested actually in linking to higher fidelity modeling tools, things like Satellite Toolkit is one I particularly find intriguing and would be interested in working with people to create an interface there.
Can you suggest some zero-budget ways to learn more about DoDAF and LML?
Zero budget, if you go online to our Demystifying DoDAF class, it's actually a webinar that we recorded, I want to say, a couple of years ago now. It's not out of date because they haven't really changed the DoDAF fundamentally since then. That's a great way to do it. It's 4 hours. So it's a little long, but I think you'll find that that's a great way, again, zero cost way of knowing a little bit more about DoDAF. A lower cost, as you'll see in a minute, is a copy of my book. That's in the $60 regime, I believe. So that's a pretty inexpensive way to learn more about DoDAF. And so then anything beyond that, you start getting a few more dollars.
Besides PES, do you support import or export from other tools such as Core or Systems Architect?
We don't have any, again, directly from those other tools. They have their own proprietary XML formats and things. We'd have to make a specific importer to do that. So there's no simple way of doing that. Plus, the other part of that is the mapping of their schemas to ours. But that's something that those are all doable things. It's just they haven't been high priority to us. What we're trying to do, in fact, is get to a point where we don't need to do that. Most of those tools can now export CSV, so we can do the CSV import, and we do that with Doors and other tools already. So that if you want to just bring the data into Innoslate, it's very easy to do that way. And you'll find that one of the things also we found is that since action diagrams are a little different than some of these other diagrams, they give you some things you don't have in the other diagrams. You probably want to redraw some of them anyway. I know particularly when I go from SysML diagrams to action diagrams, I want to redraw them because I'm missing things in SysML that I don't have, that I have in action diagrams. So.
Can the document view be exported to Word for editing and sharing with others not on tool?
Oh, absolutely. Yeah, no, it's all exportable to Word. In fact, that's one of our major outputs is a Word document. And our suggestion there is pretty it up in Word, make it look presentable, deliver it to your customer. Let them go ahead and make the comments and things like that. We don't have a round trip yet with Word. We are looking into that, but basically it's fairly easy to take comments and adjust what you need to do within the database. So anyway, that's my recommendation, and I've done that, and it's actually very effective.
How can I convince IT and security that the company's data will be safe in your cloud?
That's a hard one for a lot of people. I spent a lot of time actually researching the security of Google, which is the cloud we currently use. They actually have, to me, one of the best security models I've ever seen. And I've been doing classified computing since 1979. So I actually now trust them very much. They don't crawl our data. They basically have a randomized file name, petabytes of data for somebody. If they did hack into their the short time that they weren't discovered, they would basically couldn't find anything because there's just too much data to even begin to. So those are things that I like the Google. But the real answer is for the federal government has been FedRAMP, and they're working to that. That's where things like the DoD cloud is going to be maybe hosted. Again, one of the options they're looking at right now, I know, is Microsoft Azure Cloud, and so that's probably the future where this is all going to go. But cloud computing is coming, whether we like it or not. It's not the panacea. I'm sure everybody thinks it's going to be, but it is an improvement and is really great capability.
You said Innoslate replaced 6 tools. What are they, or what types of tools?
Okay. Well, it does requirements, so I don't need a requirements tool. It does the functional analysis. I don't need a functional analysis tool. It has built-in simulators, so I don't need simulators. I can do project management with it. I don't need SharePoint anymore either. It's things like that, file sharing kind of tools. And then I don't need a risk tool. I've got risk capabilities with it. So those are the 6 categories of tools that I've replaced. And the cost differential is about a factor of 10 in the initial phase. And then if you look at the maintenance phases, it's about half the cost I'd spend otherwise in maintenance costs.
How should an organization deal with legacy artifacts, such as paper, Visio, PowerPoint, when transitioning to Innoslate?
So one of the things is we capture everything as an artifact. We have an artifact class, and what that allows you to do is upload all this information into those artifacts and relate it to other things. So that's a very quick and easy way to do it. You also can capture pictures. Every object can have a picture associated with it. So even if I have a process diagram as an action diagram, I can have that original picture I worked from SysML or whatever I used as the baseline that I can look at and say, well, that was what it was originally. Here's what it is now. And so I can work with that very quickly and easily. And again, anything that's in electronic form, anything that isn't in electronic form, you can scan and turn into electronic form, OCR. That works fairly well. I've used that over the years to pull in RFPs, particularly over the years where they had them as PDF, scanned in PDF. That was very typical.
When you generate an action diagram, does Innoslate automatically know what type of DoDAF document it is, or do you have to label it somehow?
Well, if you use the interface to the dashboard, it automatically puts all the right labels on it. And if you'll go in there and look, you could see what those labels are, and then you can figure out how to do it yourself. It's actually very simple and very easy to do. So you can go either way with it. But I recommend for anybody new to it, work from the dashboard, the DoDAF dashboard, because that's the easiest way for you to interface.
Does Innoslate include a library of architecture artifacts for different domains?
We do not at the moment. We have put up some things on our share space, but we don't have a lot to show for that. If you have some specific things you're looking for, that's good. The other thing we do is we do training classes where we do something called a workshop, where we'll actually work with your team to get you started working with your product, your project, and translating your information into the database. And so that's actually, we actually craft the entire training course around your needs directly.
How many users do you have, and how long has the product been on the market?
The product's been on the market for 2 years. We have thousands of users. I don't know the exact count right now, but a lot of people are using it throughout. Particularly, I would say academia is using it heavily in major classes. We're using, of course, commercially it's being used by major companies, and it's being used by the Department of Defense and other places, NASA, a whole variety of people, and it's being used worldwide. We have a lot of users around the world using it. I know particularly some people in South Africa are interacting with people in England on a project, a satellite project I know about. So, so there's lots of different people using it for different things and projects.
I'm afraid that's all we have time for today. If you have any more questions, please feel free to reach out to us. We would like to thank you again for joining us for today's webinar. As a reminder, we will be following up with you very soon to send you a link to the recording and the presentation slide deck. We would also like to invite you to our next webinar in April, so be sure to check your email for the invitation. Dr. Dam has a new book entitled DoDAF 2.0, a guide to applying systems engineering to develop integrated executable architectures. The book is available on Amazon. There is also a preview of the book available on the Spec Innovations website. We also encourage you to visit our website and our blog, as well as connect with us on social media. That concludes today's presentation. Thank you again for your attendance, and we hope to see you again at our next webinar in April. Please enjoy the rest of your day.